Okay, this is Algebra 2, Week 4, Logarithms, 9-2n. So number 3, we have to solve for a variable exponent that is in the air. If the variable is in the air, you're going to need logs. In order to use logs, you need to isolate that variable exponent, so we need to divide both sides by 87 to begin with. e to the 0.3x then is going to be equal to 68.022988851. When it comes to logs, I don't round until the end. Alright, so now we're going to take the natural log of both sides for the sole reason that it'll bring that exponent out of the air. Okay, now remember, just from the last video, the log of e is equal to 1. So 1s don't change the value of anything. We'll just put that there so the graders know that I know that it's a 1. Just divide both sides by 0.3. So the log of that yucky decimal divided by 0.3 is equal to 14.066. Number 4. Alright, number 10. P of x is equal to that equation. M of x is equal to that equation. What is the solution for when they are equal? Well, we've got a couple options here. We can graph it and see if we can figure it out that way. We could plug the answers in and figure it out that way. I don't suggest setting them equal to each other because you can't drop the logs on both sides unless you get them isolated, and in this case we aren't going to be able to do that easily. So I'm going to go for plugging in the answers. 2 log of 1.65 minus 1 is supposed to be equal to the log of 1.65 plus 6. Alright, let's check it out. 2 ln 1.65 n parenthesis minus 1.00155 and log of 1.65 plus 6, and I get 2.03. Not that one. Alright, let's check the next one. So this time I'm going to plug in the 3.14. 2 log 3.14 n parenthesis minus 1 is 1.288. And I get 2.21, not even close. Alright, 2 of ln 5.62 minus 1 equal to the log of 5.62 plus 6. 2 log 5.62 n parenthesis minus 1. I'm getting 2.452. And ln of 5.62 plus 6. And hey, I'm getting the same thing. So the answer is number 3. The most direct and easiest way to go, if you ask me. Alright, number 11, graphing. If you can't tell, they do like their graphing problems. Very common. This time we've got the plus 1. So if you remember to your shifting, this is a shift up 1. So I am going to go to y equals, do my change of base formula, x minus 3 over log 2, and then I'm going to remember that whatever y value it tells me, I have to shift it up 1. Or I could type it into y equals carefully. Alright, so y equals log x minus 3 end parenthesis divided by log 2 end parenthesis and plus 1. Alright, so I'm going to go to my table, and the first place I see an error is 2. So 2 has an error. That means it's my asymptote. 3 is a 0. Yeah, I don't have any other nice numbers. So let's see, let's do 6 is 1.04, and I don't know, let's do 13 is 1.5. Just trying to spread them out a little bit because they're really close together. So x equals 2 is my asymptote. 3, 0. 6 is 1.04. 13, 7, 8, 9, 10, 11, 12, 13 is 1.5. So that's not climbing very fast. So again, do your down arrow very close to your asymptote. Go out to the point that you plotted last, just a little bit, and label. Number 12. Website popularity ratings are often determined using models. So one model for ranking websites is given here. X is the visit of weeks in thousands, and P of X is the website's popularity rating. According to this model, if a website is visited 16,000 times in 1 week, what is its popularity rating rounded to the nearest tenth? Graph it below. All right, well, if it's viewed 16,000 times and X is in terms of thousands, that means we are going to plug a 16 in for the X. So we have log of 16 minus 4, which is basically log 12. So I'm going to do log 12. Rounded to the nearest tenth is going to be 1.1, is the popularity rating, which doesn't sound very good. All right, now they want us to graph. Don't need to change a base here. Log x minus 4. Alright. Our asymptote occurs at 4. And let's see. So x, y. We have 4 is an error. 5 is 0. Alright, we'll go up to 20. Let's see, 14 is 1. And 20 is 1.2. Alright, so we have 5. They're not being nice here. Alright, so yeah, they're not being nice at all. They have 3 blocks equaling a value of 2. So that means every block and a half is 1. So there's 1, there's 2, so there's the 3, 4, 1.5 blocks is 5, that's a 0. And we have 14 is a 1. Make sure you line it up with the way they count their y-axes. And 20 is a 1.2. Eesh. So 1, 2, 3, 4. There are 4 blocks on the y's, which means every step of the y-axis is a 0.25. So we go almost up to the next one. That's drawing a straight line for me. Okay, so I'm going to put my arrow at this end. I am not going to draw an arrow to my asymptote and going down. The reason why is that this is a word problem. X is the number of site visits, and you can't have a negative number of site, well, you can't have a negative popularity rating, or at least I don't think so. I would think 0 would be the smallest popularity rating you could use. So we're not going to draw it off the graph. They only gave us the first quadrant, therefore I am not putting an arrow on the left side because it would go off into the negative range, and that doesn't make any sense for the problem. Oh boy, here we go. Alright, so this had to be a 4-point on the Regents exam. An alternative rating model is represented by that equation where x is the number of visits in thousands. Graph r of x on the same axes For what number of weekly visits will the two have the same rating? Alright, so 1/2 x minus 6. Now let's just go type it in, because I can't graph the entire thing. 1/2 x minus 6. In the first place that equals 0 is 12. So we got 12, 0. 14 is 1, and that would be our answer. 16 is 2. So I'm just going to draw this, label it R of x. The other guy was called P of x. And for what number of weekly visits will they be the same? 14,000. Now remember, these are in thousands, so when you write the number, you've got to stick the 1,000 back on, or you lose a point. 13. When g of x and h of x are graphed on the same set of axes, which coordinates best approximate their point of intersection? Again, if you know how to use flashy and do the intersection point, that would give you the answer directly. Other than that, you are limited to picking what point you think it is and plugging it in to see if it works for both of them. Alright, so we're going to plug in a negative 0.9 for the x value and see if we get 1.8 for a y value. Alright, carefully. So it's 2 divided by parentheses, negative 0.9 plus 2, and I get 1.8, so it works for that one. Now we got to type in log of negative 0.9 plus 1 plus 3 more. So log parenthesis negative 0.9 plus 1 end parenthesis plus 3. And I get a 2. Close, but not spot on yet. Now the next one says 1.9. This was 1.8 repeating. 1.9 is closer than 2. Actually, it's 0.81 repeating, sorry. Okay, so it's close, but it's not exact. So right now, number 1 is out. Number 2 is a possibility. Let's check number 3. 2 divided by 1.4 plus 2 versus the log of 1.4 plus 1 plus 3. Alright, so 2 divided by parenthesis 3.4. I'm getting 0.58. Oh, that's not even close to being the right answer. So it can't be that one. It's got to be number 2. It's got the closest set of points. 14. The loudness of a sound is measured in units called decibels. These units are measured by first assigning an intensity I.O. to a very soft sound that is called the threshold sound. The sound to be measured and is assigned an intensity I, and the decibel rating D of this sound is found using that equation. The threshold sound audible to average person is 1.0 times 10 to the negative 12 watts per square meter. Consider the following sound level classifications. How would a sound with intensity of 6.3 times 10 to the negative 3 be classified? Alright, so threshold, which is the I sub 0, was given as this. So the decibels is equal to 10 log. The intensity they want us to measure is 6.3 times 10 to the negative third, and the threshold is 1.0 times 10 to the negative 2. I would definitely make the suggestion of let's clean that up first. So I am going to type in 6.3, I'm going to put parentheses, 6.3 times 10 caret negative 3, end parenthesis, divided by parenthesis, 1 times 10 caret negative 12 n parenthesis. And so now I have 10 log of 63 and 8 zeros. So now I'm going to type in 10 log second answer. And I'm getting 97.99, and that would make it very loud. $15. What is the solution to that? And they have not actually found the numbers. They gave us some expressions. So let's go find what the answer is first. 8 2x plus 3 is equal to 48. In order to get our variable out of there, we're going to have to use logs, but we have to isolate the term with that first. So I'm going to divide both by 8. That gives me 2 to the x plus 3 is equal to 6. Now I'm going to log both sides to bring that out of the air, keeping it in parentheses because it's more than one piece. First thing I'm going to do is divide by the log of 2. So x plus 3 is going to be equal to log 6 divided by, don't forget to close parentheses, log 2, 2.584962501, subtract 3 from both sides, and we're getting negative 0.415 and some change. Alright, so number 2 is out. Let's go figure out number 1. So ln of 6 n parenthesis divided by ln of 2 n parenthesis minus 3. And I get negative 0.415. Boom. Number 1 it is. If you want to try one of the other ones just to be sure that we've got the correct answer here, you can, but number 1 is our choice. Alright, last one, number 16. Graph on the set of axes. We have to use change of base. So we've got log of x plus 3 over log of 2 minus 5. Make sure you write that on your papers. Well, you're not taking Regents, but if you were, they would like to see that. X plus 3 divided by, well, make sure you end your parenthesis after the x plus 3. Log 2, end your parenthesis, minus 5. Table, and, oops, I'm going the wrong way. Looking for the asymptote, which I'm not going to guess. Negative 3 is our error. And honestly, folks, that's because it's going to make a 0 next to the log, which you're not allowed to have. Negative 2 is negative 5. Negative 1 is negative 4. Let's see if I can find another nice one. Oh, there we go. 1 is negative 3. That's enough points. So negative 3 is our asymptote. And negative 2, 1, 2, 3, 4, negative 5. Negative 1, negative 4, and 1, negative 3. So draw it close to the asymptote going down forever. Put a little arrow there, and label it. And we are almost done. Describe the behavior of the given function as x approaches negative 3. Well, as x approaches negative 3, that's where your asymptote is. And we're going to say it goes toward negative infinity. And as x approaches positive infinity, well, as it's going to the right, it's increasing to positive infinity. Now we're done.